we've got 45 minutes for our Q&A. So we've got an app here on the iPad, so we're able to see new questions. But we'll start here with this first one. I guess, James and Michael, maybe this is for you. Why do you think it's been so hard for other fabs other than TSMC and some of their Chinese Taiwanese firms to compete on quality at the most advanced process node levels? And do you think we'll genuinely see US fabs competing anytime soon at the same level?
In the US, there is a cheap whatever. So I think there's going to be some investment in the US to have the foundries that can serve multiple people now. TSMC, I think they have done a great job for everyone. You know, NVIDIA wouldn't be where we are without TSMC. They focused on deliver these manufacturing services to everyone, and they succeeded. So, and it's hard.
Okay. James?
I think it comes down to, I think one of the secrets of their success is what I talked about. They're just trying to do one thing. They're totally trying to serve all these customers. They want to manufacture, as well as possible, and they very much come from. I think there's something cultural about it as well. It's very much a service culture they view it as, and you've seen Intel in the last couple of years try to expand this foundry business. And I'm not down on Intel, but I think culturally it's very difficult for them to come out and say, well, how do you want it? We'll do it however you like. And I think TSMC has got that. The origins of TSMC go right back to the chap whose name I've just forgotten, the chairman who was all about ironing out all the problems on was it Texas Instruments production line originally back in the day, because the secret to getting a lot of these chips to market going back several decades wasn't necessarily it was the best chip. It was just about getting the yields up. You get the yields up, you get the price down, you have a commercially viable chip. So it's not always the best tech that gets to market. It's how the process and the factories are working behind that. And I think he got that in setting up TSMC. So I think it's very difficult for others to catch up with that. And I even think TSMC will have trouble replicating that in the States. They've had trouble with hiring, and there's issues with costs, and you can't just transplant something from one part of the world to the other.
Great, thank you. Next from the love seat, Christoph.
Oh yeah, this is a very comfy sofa. Yeah, I've got a question for both Andre and Michael, I guess, which is, Andre, you quite rightly pointed out that it was slightly forced to put a graphene physics talk under the umbrella of the future of chips and electronics, and I felt sort of quite cheeky about it as well for the longest time, until actually 3 or 4 days ago, I read in the Wall Street Journal, the kind of the go-to newspaper in our office, that an article headline, "Research in Graphene shows new potential for its use in chips," based on some Nature paper that just came out, and epitaxial graphene showing ultra-high mobilities and so on. So it feels like every once in a while there's kind of a bit of hype in this direction, and maybe we kind of fell prey to this hype ourselves in setting up this symposium. But so a question to you and Michael, is there any substance to this hype? Kind of 30 years from now, will we actually have chips based on graphene? And can graphene ever take over from silicon as the main semiconductor go-to material?
For me, there is very little chance for this one. I'm familiar with this paper. It's promise which hasn't been for 20 years, and the reason is Klein tunneling, which I covered there, because you can't make transistors where electrons go through the gated region. Having said that, I think graphene shouldn't be considered separately from graphene-like materials, which I consider myself contributing a lot into this area as well. So other materials like molybdenum disulfide or tungsten diselenide. They're extremely promising in this respect. They have all advantages of graphene being transparent and making great transistors. There are integrated circuits demonstrated for those, but as said, the problem is scaling up, and scaling up growth, quality, like it happens with silicon. Initially, germanium was there. Silicon came later because only when people learn to grow silicon without defects, we get all those silicon industries. Something like this happening through. This is one problem. It's certainly solvable problem. Probably 5 years we'll get wafers of those transmission two-dimensional semiconductors, no problem with that. Then there is much bigger problem for graphene-like materials is entrenchment of silicon. Silicon makes magic. Not billions, not many trillions dollars invested in semiconductor industry based on silicon. You can't imagine that one day it just switches off. So essentially people are talking about integration of these other materials into silicon circuit. It probably will be happening. To which extent it would happen, I'm not a forecaster. It's like predicting weather in Manchester. Yeah.
Michael, I mean, just out of curiosity, is graphene or are other two-dimensional semiconductors featured anywhere on the NVIDIA roadmap?
Well, I'm not going to talk about roadmap, but what's interesting maybe in this technology, that's what caught my eye in your presentation, is the cooling. So if this technology can help on keeping the power under control, it's not making transistors, it's just making stuff more power efficient. That's where, maybe not in the electronics, but in the chips.
Pack more computation into the square footage or into the box, yeah.
Well, thank you. And I have to say, the words Klein tunneling, strangely enough, did not appear anywhere in the Wall Street Journal article, I believe. So.
Now we got the next question is about photonic-based chips. So just for those of you who don't know what that is, it's trying to use light to do computation. So rather than just having electronic circuits with ones and zeros, it's can you actually make a processing unit out of light sort of processing components. So photonics is used quite often for interconnect. We've got a question here about photonics-based chips have always been something of law with all the challenges associated with it. In reality, how far do you think we are from transitioning from semiconductor tech to photonic for computation? Anyone willing to have a stab at that?
James, it's up to you.
You see, what I would generally do is have a stab and make a terrible guess and say something really ridiculous. But because the experts don't know, I'm not going to say anything either.
Well, I think maybe the answer to there is probably quite a long way out if everybody's taken a pass on that one.
But I would just say, look, not having a stab at it, but Michael, you talked about in your talk about Moore's law ran out of gas about 8-9 years ago, I think, didn't it? So clearly the industry is looking at how things go beyond that. And you can't keep shrinking things forever, so you have to do other things. And terms like 3 nanometer and 2 nanometer are kind of not true. They're kind of marketing terms as far as I can tell, because it's not really a fair measure.
Well,
is that fair?
They changed the meter.
Yes. Yeah.
It depends in which direction you're measuring.
Right. Yeah. So I've got 3 questions here that work quite well together. I'll start with the first one, which is, I think, a question for you, Michael. How many data centers does it take to simulate all your data centers? And I guess the 2 follow-up questions are, how do you respond to arguments of an intelligence explosion where super intelligent AI systems emerge as a result of iterative self-improvement? And the third, very much related question is, of course, what do you think about AGI safety?
AI safety?
Artificial general intelligence safety.
Well, AI safety is definitely something that needs to be taken care of. The fake news is not something that, is something that we need to be able to identify and figure this out. There's some developments in this space, and it will go. The good thing is that AI doesn't have the constitutional rights, so you can just say you can do it, and that's it. We just need to find a way to enforce it and to articulate it right. I am actually aware of several technologies that are being developed in this space. Yeah. And about AI taking over of something, well, in order to take over, you need some ego. Then there is no any evidence that AI has any ego. So why it wouldn't take over?
Famous last words.
Yeah.
I guess if it happens, we won't all be here to worry about it, so that's why I don't worry about it. There's a question here actually about ARM, and it's, I guess, ARM's approach to working with everybody, which in your book, James, was quite sort of key, I think, to their success over time, was to try and be the company that everybody trusted to use their designs, and nobody ended up feeling that they were necessarily in direct competition with them in the sort of idea space. But the question here is it the beginning of the end for ARM if it's going against their original motto of working with everyone due to political pressures? This is, I guess, a geopolitical sort of spin
well,
on it.
It's a good question. I think what some people said might have been the beginning of the end for ARM is if it had been bought by NVIDIA, because that really would have been the breakdown of that business model. You were the reason that so many tech companies complained to the FDA was, clearly there will be a queue will develop as opposed to not being a queue in the past, and NVIDIA will get more from ARM than anybody else. That was the concern of the rest of the industry. I think and that obviously is one of the reasons why the deal didn't happen in 2022. But I think it's difficult to say ARM is breaking its promise, the business model is breaking down. Everyone has to follow what these export controls are. And ARM doesn't have to follow all of them, of course, because this is one instance where it is helpful to be British and not American, but the US export controls do extend over some of the companies that are not based there. It's down to a percentage of the content, I think, in each product.
Yeah.
But I don't think that's. I think what's more interesting is what Rene tries to do to get the margins up, the profitability up, and how much more involved you get in individual company's business as opposed to just being the company that's selling the rule book.
Okay, thanks. Christoph?
Yeah, I've got a question here which I think is really interesting. Somebody is asking, I want to know more about how AI has affected all three of your fields. I guess we should try and make it more concrete. So let's start with Andre. Are you using AI methods like in the discovery process for new materials or use of Lego layers of materials?
Well, I'm a reasonably intelligent person. Of course, I'm using not ChatGPT. I usually I use Anthropic. It found it's much more accurate, but depends on the task. My take on AI, I'm not an expert at all, but my take on AI is that computers can do much better tasks than humans already for many years in calculations and so on. So AI, or what it is called AI, we know that it's not artificial intelligence. It's a very useful tool for image processing, whether it's language or real images which computer processes. It's an additional tool in our toolbox, and personally I'm not worrying about what politicians are worrying about AI taking over, for two reasons. Why? To get a complexity of a human brain, even a small part of it, it would take, as Michael told us, a few percent of electricity consumed by the world. And if you're talking about a sentient AI, it probably would be a decent portion of the whole electricity, and it would be one big machine, while a human brain is happily survived on 2 bananas a day. So our architecture is much more energy efficient, not energy hungry, than silicon or any other architecture at the moment we know. And second point, why I'm rather sanguine about the race of AI is that, well, if it's so extremely intelligent, so it can't be much worse than some of my colleagues, let's say.
So we're back to the AI has no ego point.
Yeah,
Excellent.
for example, and won't start wars as we have it now.
What about you, James? I mean, you're an author. Are AI tools, is ChatGPT starting to have an influence on how you work or how your colleagues work?
I mean, probably not. Not as much as there will be. I think. I think it's. I mean, it's. I think people will be experimenting with it, but not using it widely. I mean, I suppose a lot of journalists wouldn't want to be displaced, would they? It's probably why I'm not a full-time journalist anymore.
I mean, I have to say, I mean, this week I have to write any numbers of annual reviews and this appraisal process, and I'm sorely tempted to use ChatGPT. So
I don't think you'd be the first,
See if they
actually.
notice.
Anyway.
Yeah. I've got a question here maybe for Michael and then Andre, I guess. Do we really need quantum computers? So we've seen that quantum simulations are coming up with some pretty powerful results, and also there's all sorts of quantum-inspired algorithms. Every time somebody seems to release an announcement that they've achieved quantum advantage with an algorithm, someone takes another look at the classical algorithm and tweaks it a bit and says, oh no, we've fixed it by orders of magnitude. So because it's so hard to build an actual quantum computer at scale with low error rates, do we really need to?
Well, simulation of a quantum computer is much slower than quantum computer will be. So, you know, if you can simulate the chip, why would it build it? Why do it build it? You know, when we simulate the chip, the simulation runs maybe 100 hertz. When we run the chip, it's gigahertz. So it's much faster. So I'm not an expert in quantum physics, and but the idea is that you can tackle the problem at linear complexity and not exponential. Is something that will definitely be useful when it's useful.
Yeah.
I mean, when this machine is practically useful. Right now, there is not enough qubits. You need, millions of qubits, error corrected to thousands, so it will become interesting enough in terms of, investing and building all this stuff together.
Thank you. Andre, any thoughts?
I'm not an expert in quantum computing. Okay, I know quantum physics and I know what it is about, but my daughter is doing PhD in one of the top groups in Harvard about that, and she is even more skeptical than I was about quantum computing, judging but from her 2 years of PhD. Very successful 2 years of PhD. So essentially, quantum computers are growing, many qubits, thousands of qubits recently were demonstrated working in parallel. So the question is what you can do with those qubits. Programmable quantum computer is so far away that we honestly can't even judge whether it would be there and how useful could it be. What is happening, and existing, it's quantum simulators. They have come, I think, 10 years ago, starting with superconducting annealing, and nowadays with different kind of states. So quantum simulations, which very difficult to do on classical computers, can be done using quantum computing in the lab. This is processes, I don't know, Ising model. Okay, so very interesting to simulate, but applications, I can imagine a quantum simulator which would crack this depolymerization, cracking banking codes, essentially. I can imagine those quantum computers, but they are not universal in any foreseeable future. So it's useful tool, we'll find its use in very expensive tool. We find it used in near future. How useful it would be? The same question as for graphene. It is already finding, but how useful it would be in the future, we don't know.
So the science continues. Okay, Christoph.
Yeah, so I've got a question actually to all three of you, and it's more of a policy question than a sort of actual scientific question. But I think it is quite interesting because you touched upon it, James, near the beginning of your talk. And the question is essentially, why is there no UK Silicon Valley equivalent? And I'm asking this, so I actually came armed with the printout of like the largest listed company by market cap in the world. And it's very dominated by US-based tech companies, and the UK is essentially nowhere to be seen. And I mean, you talked a little bit about choosing ARM because ARM is kind of probably the most prominent and successful example here in the UK, and yet if you look at the market cap, it's something like 1/40th of Apple or thereabouts. So why are there so few UK success stories? What can the UK government, or what can the UK scientific community or the entrepreneurial community do to change this? And relating to this, obviously, Andre, you've got a bit of experience with UK government investment into the nanotech sector, and I guess, Michael, you've kind of got the outsider's perspective. So it's a question to the three of you: what are we doing wrong, and how can we do better?
I can have a go first. I mean, I think obviously market cap is just one measure of success, and if you would look at Europe versus US, I mean, you might say that cluster around Cambridge, you can extend that. That is certainly something that looks more like Silicon Valley in Europe than many other places, and so I think there's we have all the world-beating universities. We're clearly innovating. A lot of those ideas are getting commercialized. More could be, and that's probably a question for Andre. But I think part of the challenge is how does, if in footballing parlance, how does the UK stop being a selling club? If you see what I mean, how do you go from building a great idea, commercializing it, putting a lot of the effort in, and then selling it at 100 million, 500 million, billion, and that's where a lot of the work in my day job as well is how do you make sure that you're linking the universities up to the stock market and getting companies to not just start here but to scale here and to stay here, and I think you see the evidence of that. ARM is a good example. It's not my only case study, by the way, but as soon as we're talking about it, people say now, is ARM British? There's a greater concentration of the top management on the West Coast. The company still calls Cambridge the headquarters. It's the largest base by far. It's got almost 3,000, very well-paid staff there. But would you have a company with roots so deep in the UK if it hadn't had 18 years on the UK stock market? I think as soon as brilliant UK tech companies need to look abroad for funding, then they are more likely to uproot completely. And it's all very, very fluid. People move, capital moves, and so on. And so we need to focus down on how we capitalize on universities. Sorry, very long answer.
Okay. Michael, what's sort of the Israeli perspective on this?
Well,
What can we learn
I
from
think
you?
it has to do a lot with two things. One is encourage people to think out of the box and not afraid to fail. That's one thing. The other thing is sort of more objective, is the size of the market. And when we started Mellanox, it was 99, more than 20 years ago. Our dream was to build large Israeli company. And so we got to $7 billion worth of, and then NVIDIA acquired us. And if you look at some objective criteria, it was the right decision for everyone. But we are not Israeli company anymore. So there's a big inertia and big market forces that sort of it's natural for the big companies to be where the big market is.
Thanks. And Andre, any sort of lessons from the sort of investment into graphene in the UK?
I have an opinion about this, which is different from James and Michael's ones. I think one of the biggest problems is a cultural one. In the US, there has this spirit of Wild West. If you and in Israel as well, if you ask PhD students or university of graduates what they would like to be, they typical answer, we would like to work for a big bank, for a big company, to be civil servants. So essentially, UK universities nurture civil servants, in my opinion, and it's kind of long-term problem for this country, and this is statistics. Okay, I think 1 in 10 people who were asked this question, whether you would like to open your own enterprise, only 1 in 10 with even less than that, with the roots where the father or relatives run a small company. Now, these days, you see the same kind of safety net attitude, the lack of adventure to start your post-university studies also touch United States with what it is called DEE, diversity, equality and inclusions, which killed Boeing, for example, or quality at Boeing, as some people say. So I think it's for too long was too safe country, Britain, unlike Israel, and I think the spirit of adventure in the America, we'll see how it goes. It's a little bit better over the last few years. I mean, not that economy has become worse and people has to be more enterprising, but okay, at least our students sometimes in Manchester show interest in open their own companies. But it requires a strong shake-up or cultural shake-up.
There's one here, Michael, maybe for you, I guess around the kind of the feasibility of this continual increase in compute requirements. So you had your sort of million X in 10 years graph there. So it feels natural that people will apply Monte Carlo tree search a la AlphaZero to do self-supervised learning for large language models. This will probably need a lot more compute, however, maybe another 2 or 3 orders of magnitude. Is this even physically feasible, or do we need some kind of totally different compute substrate or approach?
Well, if you asked somebody 10 years ago whether it's feasible to do million X in 10 years, the answer would probably be no. But that's what happens because that's what we demanded, we as humankind. Mm-hmm. And if humankind will demand another 10 million increase in 10 years or whatever, that will happen. How it will exactly happen, I don't know. But what I know is that since the beginning of history, whatever needed, people manage it, to figure it out how to deliver.
Do you expect that'll come through innovation rather than just using more power, for instance? Yeah.
And the thing is that I like to work with the young guys because the experience there is a value of experience, but experienced people usually know what can be done and they know what cannot be done. They do great what can be done. They don't touch what cannot be done. Young people don't know the difference, so sometimes they do what cannot be done. And
without even realizing
it. And I have multiple examples on people I worked with that just did it.
Yeah. Okay, thank you.
Cool. I've got a question here, probably summarized as the minority strikes back. Those people who lost the internal poll on this frogs versus cones question are now piping up. And one question here says, what was your favorite part of the levitating frog experiment? So I'm not entirely sure what that means, kind of favorite part, putting the frog in, taking the frog out. But I think maybe maybe as a chance to make amends to the minority, do you want to kind of very briefly summarize what you did and actually why it was interesting and not just kind of animal torture?
Yeah, it was unexpected. It started with scientific question, okay, what can you do with water in high magnetic fields? And when my colleagues didn't believe that water can levitate in the magnets they have used for 50 years before, and no one has done such a stupid thing as pouring water on top of very expensive equipment as I have done. Water levitated inside the magnet, and I thought that was it. And then colleagues didn't believe. They came with all those brilliant ideas. What else can be put inside magnets? Paper, water, strawberries, tomatoes, everything else. And eventually I was so fed up that I put a frog inside, make a picture of this frog, and thought that forgot about this one. And then some journalist, okay, I blame your profession for this, discovered this picture of the frog, and then it was another hype about everything else, and otherwise it was a little experiment. But I usually say that sometimes I go to large conferences like March meeting in the US, more than 10,000 people, and someone stops you in corridor with saying, "Oh, I know you." I roll the eyes, okay, but again about Nobel Prize, I fed up with this kind, and the guy tells me, "Oh, I don't understand anything about graphene, but your frog." And this is the most pleasant experience I had about this. Yeah.
Excellent.
Okay, thanks. Question here, again from the audience. Our speakers have given an optimistic view of the future, which is clearly great that you've got positive views of what's ahead. But what's one thing that keeps you up at night, or maybe makes you concerned about the impact of the very rapid advance of technology? So this isn't necessarily an AI question. I think this is more broadly about the technological kind of pace of development. Is there anything about that you worry about? Michael, maybe you go first.
Worry is probably not the right term for my feelings. There is a lot of things that you need to be concerned of, but looking forward, you just think about what type of things you can do that have not been, that don't exist. And when we started Mellanox, our vision was to have computing as a service like electricity is. It was sort of vision that very few people shared 25 years ago. Now it is reality. So when you think about these type of things, then you can, and that doesn't happen every day.
So you remain positive, actually, generally.
Yeah.
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 Okay.
Well, there's, again, when you are in this business, you need to think about that you are going out of business very soon. So what you are doing to be absolutely best, and when I think about the products and technology, it's not that comparing my stuff to somebody else. It's just comparing my stuff to things that I can theoretically, the best possible theoretically think. In NVIDIA we call it speed of light. How you can run as fast as speed of light theoretically now. Now you need to approach this bar, and then you are fine.
Yeah. So I guess I'm going to read between the lines here, but I guess that would translate as a fear of complacency then, maybe. So keep going towards the thing you're aiming towards, and don't let yourself lose that vision. Yeah. Okay. James?
I think I think US-China is quite worrying. Clearly, there's been rapprochement meetings recently, but it's a long way from being resolved. And I think the more that the US seeks to tighten its grip on export controls and what everyone else can sell into China, I think domestically China redoubles its efforts to strive for silicon self-sufficiency. And one of the unforeseen events for the US could be that a lot of international tech companies, hardware companies, look at designing out US components. So I think the industry, the world has had decades of advance because pretty much the whole world's worked together. And so if you have this region doing this and this region doing that, it doesn't feel particularly positive.
Thank you, everyone.
Thanks. Actually, this is all comparatively uplifting relative to one of our previous G Research Distinguished Speaker events where like a cosmological astrophysicist was telling us that we might be swallowed up by some vacuum instability bubble at any random moment. So at least we're still here. We probably have a question, time for one last question. And I think that this is probably a question to two of you, actually, Michael and Andre, because it sort of pulls together the materials physics and the quantum computing. Somebody's asking, can topological insulators be the material for quantum computing hardware? And you have 10 seconds to answer the question.
But we did have 5 minutes.
We can overrun. So.
I don't know how, but people do that. Okay, it's already there are qubits based on silicon, based on HBM, and so on. So qubits are there in two-dimensional materials. So I don't know how, but eventually we have a toolbox, and this toolbox will be used one way or another. Like we get germanium, silicon, we get copper, gold, we have two-dimensional materials now, we have quantum computing, we have to satisfy the demand. It will happen. The toolbox is there.
And of all the approaches to qubits and quantum computing, from a physics point of view, which one do you think is most promising for applications?
Anyone guess? You ask anyone out of 20 different directions in quantum computing, and everyone would claim that his direction is better in this way or in that way. So you can't really say who will win the competition. We need to put resources behind those, all of them, I believe.
Michael, you're smiling.
Yeah.
Do you have a?
No, I'm pretty much agree. I'm not a physicist. I'm not in the details of this. Demand will come. We'll figure out. We, as a humankind, will figure out how to satisfy it.
But you don't see a front-running technology emerging just yet.
Well, I'm not in the details of this technology. We watch it closely. I mean, in NVIDIA, we have a team of people that are looking at this, but it doesn't seem to be on the horizon.
Okay.
It's great.
Thanks.
Thank you. Thanks, everyone. So time is up now, officially. If we go any further, I think we'll get in trouble. So once again, Christoph and I would like to thank our 3 amazing speakers for today, and also the team for organising this event. I mean, I think you'll all agree this has been a fantastic venue. It's all worked really smoothly. We've never had AV work this well in the office before, so congratulations to the team. Thanks to the venue themselves. Yeah, maybe. So thanks to everybody for coming. Thanks to our guests for coming to speak. Thank you.